We're building this photo booth with a group of, a mentor group that I run on Thursday nights in Chattanooga. And what's interesting is that we have programmers from all walks of life, and it's mostly a group of women and minorities. And so the focus of that group is to advance people with Elixir in a way that they could take it in a professional direction. So I want to talk a little bit about that. So one of the things that you'll notice about this picture, this is at our conference last year, they're all women. And I think that that's a cool thing. We actually had a target for the number of women that we wanted to bring to the conference. We said that if we got a 10% number, then that would be pretty good. We expected 80 people at the conference. We wound up bringing in 33, right? And I think that the reason is that we focused on diversity at the speaker panel and mentoring people so that we didn't drop people into the conference cold. And when people felt welcome, they came, right? So one of our focus elements in our mentor group is that we don't teach Elixir just for the purpose of teaching Elixir. We teach Elixir for the purpose of advancing people in their career. So the other thing is I'm a strong believer in the idea that if you want to build a better community, you imagine the community that you want to be rather than try to adopt the one that you are, right? So I won't say too much about this effort. What I'd really like to talk about is the idea that if you have a mentor group with vastly different capabilities and you have very few mentors, how do you go about teaching that group? It's a pretty interesting challenge. So we talked about the idea of building a photo booth. We'll talk a little bit more about that since we didn't have the opening video. Basically, we're building a Nerves Scenic project. We started with a Raspberry Pi, and with that Raspberry Pi, we have a 7-inch little display, probably about that big, and it'll count down and basically take one picture, then another, and then another. And then you pick the pictures that you want to send to the big screen in the conference, right? So it's a great way for us to kind of show people what's happening and what you can do with Elixir and kind of showcase the mentoring effort at the same time. And as we were building this photo booth, there was a guy, a troublemaker, his name is Seth, and he was in the back of the room. He says, "Ooh," and I thought that I'd kind of broken through or something. He says, "No, we got to do a troll mode." I said, "A troll mode? What's a troll mode?" He says, "How do we get people to take bad pictures," right? So there's a secret button in the back. You push the button, and then you take bad pictures, right? I say, how do you make people take bad pictures? And then all these ideas started pouring out of the group, right? So one of the people said, well, maybe we count down, but instead of seconds, maybe there's like milliseconds, and then longer groups of time. So that really throw people off. Or maybe, as you're counting down, you take the picture then, right? Or maybe you let people pick the pictures that they want, and then you send the other ones up, right? So there's troll mode. And so very early on in the process, kind of that little chunk of fun had people investing in the whole deal. And we also learned something else, that there are people that are pretty mischievous. And we needed to have censorship for the photo booth with somebody that we trusted so that the project kind of grew in complexity when Seth said troll mode, right? So we said, okay, so we'll take the we'll take the pictures, and then we'll send the pictures to an admin console, and then we'll send the pictures, we'll let people accept or reject those pictures, and then we'll send them up to the conference. And we'll have that on a loop kind of between the talks and things like that. And so I think that one of the things that's cool about the project is this gave us a lot of opportunities to teach Elixir concepts in different ways, right? Because all of these things have one particular model in common. There's a functional core where we could put some of the beginning people, and then there's a boundary layer where we could have people coding the OTP loops, or the Scenic loops, or the LiveView loops. And so that could let us focus some of the attention of the mentors, right? So that's the next thing I want to talk about. How do we break down the overall project into concepts that we could then teach and kind of use as the curriculum for a year of our mentor group? So one of the things that was really important for us was to define a learning path that everybody would walk down together. And the first thing that we thought was important was, how do you navigate the tool chain in a new language? So some of the people that we work with have never actually written a line of any kind of code before. And it was important for them to learn to navigate the command line and actually learn how to use Git and actually learn how to use an editor and even kind of multi-cursor cursor things and things that would motivate them to kind of get proficient and feel good about being a programmer. So then, as soon as they had the tools installed, we tried to have people get to high order functions as soon as we can. And that basically, even though most of or a good chunk of the people had never had any programming experience before, all of them had little bits of experience, maybe in JavaScript or maybe with a one weekend code camp, or maybe even just reading something before coming to the group. We wanted to kind of break down some of those early mental models around object-oriented languages and JavaScript so that we could get them thinking in Elixir as quickly as we could. So we moved them we had some exercises with higher order functions. And we called the group that was focusing on those two things, they were our beginners, right? And Dave and I at the conference last year actually got to talk to a chunk of them. And one of the things that we talked about was how to build this mastermind game, right? And how to basically think about tiny functions in that mastermind game. And so I would say that within this group, the thing that we focused on the most was actually problem solving. Actually, Dave and I talked with his son, Zach Thomas, about the idea that to teach, you really have to be able to take big problems and break them into smaller ones. And without that, you just can't have any success. And without that success, you can't build the confidence. And so to do that, we haven't really broken through with any kind of curriculum, but we have found that one-on-one mentoring is very effective in this area, especially if we do this test-driven development. So who has used the site exorcism.com? Right, so we do a lot of that in the class, right? And so the first couple of exercises that we do are the really basic ones where we're trying to write a single function. Well, first there's the hello world, and the other ones we're trying to write a single function that has some simple outputs, right? And the way that this is structured is that you have a blank canvas where the code would go, and then you have actually the structure in the form of the test. And we find that this is pretty incredibly productive for the students, especially since they have the satisfaction of filling out the blank canvas on the coding side. So we also wanted our beginners to be able to participate in the photo booth. And a great way to do that is to have them help with the with the requirements, right? And you can imagine there's a lot of little questions that we have to ask. And probably you could probably guess which question, which requirement we spent the most of the time on, what goes into the troll mode, right? But what was interesting about teaching this group is that we initially had technical requirements when we said, okay, you're ready to move from this group to the next one. But really, moving from one group to the next was based on how the candidates saw themselves. Right? So when they said, I think that I could do this, I think that I could use this, and I really want to start to commit to this project. That's when we said, okay, this group is ready to move from the beginners, and they started to see themselves as programmers. It was really, really important. So the most important things that we worked on with the programmers are essentially thinking in terms of functions and transformations. So Dave Thomas in the front row here had a book that was pretty important in how Elixir development got started, right? So how many of you saw Randall Thomas's talk right before this one? Right? So he talked about the pipe, right? And how important that's always been to Elixir. And in fact, that's not necessarily true, right? So Jose got the pipe from a language called ML. And he basically saw the pipe as this kind of cool technique. And what Dave did is he built his book around this idea of taking one function and feeding it into the next and thinking in terms of transformations. And when we can get a mentee to take that step, then that's actually the critical step to learning any kind of programming. How do you break down a big problem and turn it into several little ones, right? Then after we do that, we've got them, right? So if there are various inputs that they have to change, well, that's another little pipeline. If they have a function that they don't understand how to write, we have an input and we have an output, and we can break that down into smaller problems in between. Right? Once we get them to solve that problem, then we've got them. And so some of the exercises on exorcism that we like, there are a few of the ciphers, like the at-bash cipher. Actually, it's pretty easy to take a list of characters and then reverse it and then stitch those together and then kind of build a map and read from those. So we really like that one. There's another program called Bob that we've kind of tinkered with a little bit. And Bob is a surly teenager. You might give him a response, or you might give him some input. You might say, whatever, right? So that's the default. If you shout at him, he says, chill out, man. So what we did with this exercise, we basically extended it to let people code their own personality. Right? So then we could take beginners, and then they could have some input in the creative process of how they wanted they could basically build their requirements, they could shape the tests, and then they could solve that problem, and we could build all those multiple personalities into a single code base that we built together. Right? We found that was pretty effective. And as they worked on the photo booth, we said, okay, well, if you can problem solve, and if we could build the shape and the requirements, it was relatively easy to fold those people in to the pure layers on pretty much every piece of the project. For a camera, it would be thinking about the flow of the thing that we were trying to build. You're counting down, you take a photo, you optionally take another photo or send the photos, and then you finish. Right? Or with the admin layer. We started this with a pure functional layer that's driven perfectly or pretty much completely by lists. Right? And then later we replaced the list-backed admin with the database-backed admin. Right? And those functions look exactly like you expect them to. Accept a photo, reject a photo, create another photo. Right? And of course, the slideshow is pretty much very simple. It's just looping over something that says, get the next photo, and that whole thing is rolled up into a slideshow. And we thought once again that when somebody graduated from, that we could define some type of technical requirement for when somebody graduated from the coder group and moved into the next one. But again, it was about self-belief, right? People couldn't take the next step without buying in and saying, I want some dedicated time outside of this group to attach myself to another mentor, right? So we provided the opportunity to do that when they said, I want to take the next step and learn Elixir, actually invest some time outside of this group, right? And so our last group was called the professionals. And with the professionals, we think that if we can teach people that piping is just a special, is just a reduce in slow motion, and once you have the reduce paradigm in your head, then you can start to think in terms of OTP, which is another reduce where instead of pulling from an enumerable, I'm pulling from a message queue, right? And so that's just a reduce in slow motion. And then once you have OTP, then we could fold people into LiveView, which does the same thing. We could fold people into Scenic and actually start to solve these problems in the same way, right? So basically, we moved on from a flat world to a more distributed world with concurrency. And we focused on accountability and meeting directly with mentors in the community one-on-one. So some of the exercises that were important to us to actually make the breakthrough, Exorcism has this thing called a robot simulator. We actually, once again, we said, okay, well, what if you coded this and you had another business requirement that this was a drone, right? You had ups and downs also, so that they could not only get the experience of solving the test first version of this, but they could actually build their own requirements, roll in tests, change somebody else's code base, and really get the use of, the idea of flowing through the whole tool chain. So we could also start to use this group in the more complicated places in our photo booth, right? So we could build an admin, but rather than the list-backed version of the admin, we could build the database-backed version of the admin, right? We could have them actually start to worry about the external interfaces, the lines between the systems. So Seth, one of the guys in, so the guy that came up with the troll mode, actually did the send and receive over HTTP. And then we actually worked with some of the mentees on some of the things that required a little bit more learning pain, if you will, right? Like saving to S3. And then there's also the creation of the Scenic user interface and the LiveView interface. And in this area, we could start to specialize people to say, hey, do you want to work more on the user interface? We have some experts in usability that would actually work with our mentees. Right? So the most interesting thing that came out of our group of professionals is that people graduated and wanted to stay part of the group. So they said, I want to be mentors in this group also. And pretty much this happened after something big happened in their career and their job and the company that they work on. So a couple of them have gotten jobs, one with Google, one with the company called Metatrack. So we're not trying to do placements at the back of the line, right? We're trying to get placements with very good programming jobs, functional programming jobs. So some of the people have gotten jobs, and we're very close to getting better jobs for a couple of the people in the group. One of the guys that's actually in the group is there because he wants to, he has a company, a programming company, using JavaScript, and he wants to fold Elixir into that. And he's one of our most consistent mentors now. Okay, so I'd like to talk a little bit about the code and show some of the lessons in progress. You can get to everything that we've written, the logical camera and all the other pieces at Elixir Chat, and that's 2 T's, on GitHub. Right? So I'd like to look first about some of the pure functional layers that we're working on. And if you squint hard enough, you could see them as reducers, right? And the shape of the function that we're looking at is something that takes some type of a struct, you call the function, and it transforms it. And we did this over and over with various problems. And we took it from the pure functional layer with the counter, it's just x plus 1, right? But then we would build our own OTP servers with threads. And then we would fold in OTP. And then once we'd done that, we'd do it again with a stack. And we do it again with a game. And then once we were ready, we could move into the photo booth. Okay. So this is an example of some of the code in the repo. And we use very short functions that we would pipe together. Right? So in this area, all we were doing is saying this is map update syntax. It takes a booth, it returns a booth. That's exactly the type of function that we're looking for. And then we said, okay, if we have enough of those, we can start to layer those things together to actually work through the flow of our photo booth. Right? So one of the things that was tricky was we wanted the students to be able to get an idea of the flow of the photo booth from end to end. And so this is a pretty cool code example. So if you don't pay attention to anything else, pay attention to this one. Right? So again, we're talking about piping reducers together. But this is the way that we structure our tests. It's beautiful, right? Because it says we start with this photo booth, and then we count down a couple of steps. Now we're doing it with instructions. Later we'll be doing it with OTP events. Then we throw an assertion in the middle, which won't work if it's a pure assertion, but there's a little trick that we played. And then effectively we could continue the pipe, right? So we could count down and make sure that that was that we changed the mode from counting down to shooting, and that we actually reset the countdown counter, right? And here's the ninja move. You might be looking at this and say, that shouldn't work, right? Because this thing makes it a reducer, and then you say, well, how do I return the assertion? Well, but you're not returning assertion. An assertion is a side effect, right? So I could take this side effect, and it feeds off, it does the OTTP communication. It sends a message to the collector for the test data, and then I can have a flow that looks like this, right? And so now it's very easy for me to teach my students what the flow of the whole thing looks like, right? And so at some point we start, our mentees kind of graduate from that intermediate group, and they start to get what reduce does. That it's just this pipeline that kind of collects the items, and we use enum reduce on that. And then we could say, okay, you see this items right here. Well, they can come from an enumerable, or they can come from a message queue, like they do in LiveView or Scenic. So we have something like this, right? We have a state, an initial state of 1, and then we pass it to our reducer, right? And then we take that and we feed it back into the counter, right? And we did that with the stack. We did that with the game. And then we could start thinking about doing this in LiveView. Now, the cool thing about LiveView is that it's almost the same thing, but I throw in this render piece in there, right? And that's a pure function. So I could say, okay, now we could assign some initial state, and we could build out the whole user interface of the slideshow, right? Or the admin page. Like for example, this is the first commit where we were hard coding that function. So again, all we're doing is taking a look at this render piece, right? So I assign some state, and then I could say, okay, so take these and fold these into the HTML. And they did, right? And then I said, okay, so that's part one of LiveView. You've got it, right? So now all we have to do is focus on the other part, which is just OTP, which you already know. So these are just handle events. You already know how to do these. With handle calls and handle casts, it's the same thing, right? And then, so you see these have these accept and reject functions. All they do is update state. With a reducer, assign is just a reducer on socket. The same thing works in Scenic, right? But instead of a socket, I have a graph, which is nothing more than a reducer. And so I thought I'd talk a little bit about breakthroughs, but I want to talk about my breakthrough first. So one of the things that I noticed was that we were getting people assigned, we were getting people employed, but actually in none of our placements so far is the person actually coding Elixir, right? They're actually getting better jobs based on what they know in other languages. Gosh, I wish I could make this sound work. What's that? To the computer, so it's there, right? Oh, I see. Okay, yeah, let's do that. So, okay. So one of the breakthroughs, the biggest breakthrough was my own, right? And as these mentees started getting job placements, I started to see, well, wait a minute, one of the things, if I'm supposed to be a language learning company, and one of the best ways to teach my mentees was to teach them different languages to get employed in something else. And in my career has moved most quickly as I've learned other languages. We're doing a program called Programmer Passport, right? And it's a subscription-based model to learn programming languages. I think that's pretty cool. Okay, so let's see if this idea will work. What's that? We can try with this one. Okay. Actually, yeah, great. So rather than show than tell you what the breakthroughs were, I thought you'd like to hear in their own words. Everybody hear that okay?
What's the first programming language you ever used?
Python, probably.
And tell me about your programming.
Well, I started out with PHP. Then I learned Python and C++ in school, and now with our world of JavaScript, kind of forced into that paradigm.
What was your first programming job?
I can make it better.
And what did you code there?
I did Elixir and JavaScript.
And what else?
And Ruby.
What language do you do for work?
I'm using Ruby currently and working towards learning
This is
Elixir
Grace,
as
who
well.
just got a job at Metatrack.
That's a lot of different languages for your first job. Was that a mistake, having that company teach you so many languages at once?
Definitely not.
Why?
Right, got a job at
Well,
Zillion.
just because it exposed me to thinking about problems in different ways.
But wait a minute, so in our mentoring group, you use what language?
Elixir.
So why in the world would you want to learn so many languages at the same time? Does it make learning harder?
Not really. I think even though they're all have different parts of them that are different strengths. I think learning them all at once gives me a better idea of what's special about each of them and how they're all similar as well.
Why would you ever use a new language like Elixir when it's a JavaScript world?
It's fun and different.
Seth is moving his company to Elixir.
Does fun help you learn or no?
Yeah.
Why?
Because then I'm actually engaged in it and I have a reason for doing it. Because I feel like a lot of times when you're learning how to program, it can feel very like, here's the syntax, here's how you do it, okay, now you can go do a big project. But when you have, like, when it's fun early on, you continue it.
How does fun accelerate learning?
Well, I mean, it's hard to want to learn something if you're not enjoying the process.
How do you make programming fun?
A couple different ways. I mean, challenging yourself with something very different. So then you have something that isn't what you're used to, so it's not as boring. And then doing it with people, I think, is another way to make it fun. They add their own different flavor to it.
Tell me about your experience learning computer science in college. So what are some of the things that have worked for you?
Not the stuff they push you to do in college. It's everything about what you do on your own, I think. If you have a passion for it, if you like it, everything you do extracurricular is what has helped me at least.
What's the hardest problem that we've solved together?
Reducers.
Definitely the robot one. Just because, well, lots of different reasons, but I was going about it wrong at first. And then I didn't also know what all the tools were, but then once I knew what the tools were, I was like, oh, I can just use this reducer, and that puts everything together. Instead of me trying to do it manually.
This past week, I've been working on a project. It's a
Errors is data.
exercise application for the health department in Kentucky, and the application itself is built on Node.js. It started to grow quite a bit, and just the language itself. I'm starting to see so many things which have gone wrong. But the worst part is this is the worst part I've ever seen when my whole programming career is not seeing an error. Like, I know things are not working the right way, but I can't even see an error. So then I'll try to break the code, and when I see an error, oh my goodness, does that make me happy? Like, it's just a weird thing. And then whenever I go to Elixir something, I see the error, and I know exactly what's wrong.
What?
It's just more intuitive. It's more the way that the functional language is built is just amazing.
What makes you learn faster sometimes than others?
If you can be exposed to different ways of working through the problem, so different programming languages, being exposed to different programming paradigms which you're going to encounter in different programming languages and things like that.
Yeah, so that's basically where we've started to take the company. Learning is fun for the sake of learning, right? So that's all I've got. If you guys got some questions for me.